Hello, welcome back. So let's focus ourselves now on chapter 8, which is called Manage Start Stack. The previous chapter was chapter 7, I said was chapter 6 about basic partitions. Doesn't really matter. Roll the intro. And the intro's coming. All nice. Like and subscribe to the help. And okay, here we're back. So let's directly go to, I don't know, here maybe? Looks nice. So let's get our Rocky 2 back here. So this is this is on the same exact point where I believe the previous video was dropped off. I said it was chapter 5, but it was 6. It's in the title and on the thumbnail, it's fine. So yeah, so let's discuss what is the name of the chapter again? I forget. Manage Start Stack. So in other words, we're going to discuss two things. One is LVM and the other one is stratis. Okay, I'm going to go through LVM and stratis, but let me tell you right now, I don't like stratis at all. I think that if you are running a production environment, just avoid stratis, because that's not something I would trust at this point. But I will show you quickly how to set up stratis, and I highly advise you to test everything out for yourself, like any other subject of this video series, of course. But stratis, just be careful, because stratis, it's I don't trust stratis. Okay, sorry stratis people, it's just too early to trust. So LVM it stands for Logical Volume Manager. It's been here with us for the last, I'm not sure exactly, but 20, maybe almost 20 years. So it's very trustworthy, and it's also a kernel feature, which means that it's embedded on the kernel, and it's a kernel that manages. There are kernel level drivers and all of that good stuff. So you just reboot the server and the drives are there. No big of a deal. While stratis, it's a service. It depends on the service. So, well, but then again, I'm not going to try to influence your mind too much, but I don't trust stratis, but I do trust LVM. It's been here for a while and it's really trustworthy. It's a kernel feature LVM. Stratis is a drive. It's a service level service, so it depends on the service to work properly, and it kind of makes me nervous and I don't like it, but I will show you anyways how to set it up. But let's discuss LVM first and foremost. If you remember, not yesterday, well, I recorded that video yesterday, so it's if you do lsblk, you'll see that in our case here, you have these LVM drives here. I will get into that detail in a second. And also, if I go to the partitions, you can see that you have here these DM0 thingamajiggies. So these are the actual LVM drives on the perspective of the kernel. All right. So let them be. This is the exact point where we left off yesterday. The machine just rebooted a couple of times and it's fine. Everything is mounted automatically through the fstab file. So everything, it's pretty great. Now we have some space here on both drives, on the GPT and this is the MBR, on the MBR drive and on the GPT drive. So let's fool around a little bit with those to set up LVM. But before we do set up LVM, let me just give you a quick rundown of what we're going to do here. Really, it's really simple when you get the hang of it. So what is the one of the main advantages of LVM? There are more, okay? The more picky guys around here, don't get nervous. Okay, this is just me specifying, explaining things in simple terms. Don't get too nervous about this. These are just simplified versions of the thingies so people can understand. So one of the things that you can do that you cannot do with regular partitions, either being primary, extended logical, or GPTs. So one of the things you cannot do with those type of partitions is resizing. Again, some of you guys are going to say, but I know how to expand and shrink regular partitions. I know how to do it. There are tools to do. Okay, fine, but they are not. Those tools exist, but they need to be used with care. They are not supposed partitions like primary, extended, logical, GPTs. They are not designed to be resized once they were created. I'm not telling that it's not possible. Everything's possible in life if you put your mind into it. but you should not resize primary, logical, extended, or GPT partitions. They're not designed to be resized after creation. Yes, they can be done, but I don't recommend that. But LVM, yes. So LVM, it's a way to get to a partition that is resizable. Okay, you can shrink and you can expand, being expansion the most common thing because of obvious reasons. But logical volume manager partitions can be resized, and that's something it's supposed to happen. For example, if you have a support contract with Red Hat and something goes wrong with the LVM resizing, they will help you out because that's not normal. You get support and all of that good stuff. If you try to resize primary partitions, extended partitions, logical partitions, GPT partitions using some crazy tool that you saw off the internet or someone that promised you that it would happily occur, or you don't read the fine print on those tools, you may get yourself into trouble. So how does this work? Well, first, let me just get my mic out of the way. I really need to use my wireless mic, but let's carry on. So first, you just get some space, okay? This is physical space, so this is called, let's call this a physical partition, okay? So this is just a partition, or like we create one of the ones we created on the last video, or a full disk. Okay, you don't have to partition your disks in order to create LVMs. You can just use a full disk. It's just either being a physical disk or being a cloud-based disk. You just need to get some free space, some physical space to the kernel. It can be a partition. It can be the full disk. Doesn't really matter. Okay, so let's say this this is a 1 GB big physical partition or a physical disk. Just free space, whatever it comes from. The system does not care. Proc partition shows it, lsblk shows it, you are okay to use it, okay? Physical space, something physical space that the kernel can work with. It can be a full disk or it can be a partition. It doesn't really matter, okay? Then you're going to promote this to a PV, and PV, it's a physical volume, okay? Let me try and write this down a little bit better. It's a physical volume, and it's going to have the same space of the partition. So physical volume, it's kind of you load in a special driver that is going to represent this, show to the kernel that these are available spaces. Okay, so you start with a physical partition, and then you will afterwards promote this to physical volume. Physical volume, it's LVM driver loaded. It's just a special driver that the kernel loads, so it can be seen as something special so all of the rest of the thingy-majiggy will work properly. Then you will create a VG, which is a volume group, and a volume group has the capability of grouping multiple physical volumes. Okay, for now I'm going to create a very sad volume group with only one physical volume. But in this case, it's going to have a 1 GB size because it's as big as the ones below it. Okay? Volume groups are great because you can, well, they are groups, right? So if this gigabyte runs out of space, you can just get more storage and expand this VG, something you cannot do with physical normal partitions. Okay? Then on the top of this, you'll have an LV, finally the logical volume. And logical volume, it's kind of, if you think about what you saw in the last video, that were the logical drives. So logical volume is kind of a logical drive. So it's a kind of the end of the road. This is what you format. You will format this and mount this. So you make mkfs here and you mount here. This is the thing you format or make a file system, and the thing you mount. This is going to expose this to the user. Okay. What is the upside of this? I will show you in a second step. We'll do this step by step. But the good thing is, if this runs out of space, this is full, okay? You just need to go to the bottom of the line where we started off, for example. So this doesn't have space. You need to provide some extra space here. Let's say another gigabyte. You just load the physical volume driver of 1 GB, and then you expand this over here. Now our VG, it's 2 GB big, which is made of two 1 GB spaces, which means this thing can grow as big as this or create 2 extra ones, etc. If this runs out of space, you just go back on the bottom, get some free space, load the special driver, expand the volume group, then you can give space to the rest of the family. Okay? that's one of the main things that you can do with the logical volumes, is to the expandability and the flexibility of managing your free space. Okay, but let's say this guy here, we can shrink one to expand another. So this is kind of a pool of space where the LVs can grow and shrink at your leisure. If this space runs out, this is kind of the base things, right? My head just fell off. Okay, let's see him fall off again. Okay, so then you can, if this runs out, you just need to add some space in the bottom and some space here. This will grow, and so on and so forth. This is a one volume group, but you can have multiple volume groups in your system for different purposes. It's all fine. Okay, so rewind the video a couple of times and rewatch and rehear me explain this if you didn't got this clearly, or wait for me to do the practical demo and just rewatch it again. Let's put here a white space so I can just keep drawing what I'm actually doing in the console. So if I go here, what do I have? So I could use this because this disk is 22 gigabytes big. I still have some space for logical partitions. You can use logical partitions, you can use primary partitions or full disks. It's all good, it doesn't really matter. But I'm going to use a GPT one just because I can. Okay, so let's go to gdisk and let's start to edit this guy here. You guys can see it? Yeah. So let's print out what we already know. New partition, it can be number 3, I don't care. You can start here. It's going to be, let's keep the 1 gigabyte thingy-majiggy. Let me get some, clear my view. Cool. Now, here you could use any type. 8300, which is the standard word, will work fine. But I do recommend you guys use the LVM one. So I know it from the top of my head, but 8E00, it's not still visible. It's there. Okay. So this is the one we want. Oops. Quit. 8E00. Print. All good. So this is not mandatory. Okay, this is not mandatory. It's fine. You can use standard ones. You don't have to mark this as LVM, but on the long run, it's recommended. Okay. So I'm going to save this. Yes. It's now making the changes. Let's do the part pro like we did on the last video to synchronize the changes to the kernel. If I do lsblk, there we go. It's there. It's fine. It's happy. And we should be pretty good to go. Okay, let's just do an lsblk. It's ID. Let's go to the gdisk once more. If we print Linux LVM, it's fine, and we quit. Cool. Now, what we have now? Let's go back to our specific drawing. Now, what we did here was create a physical partition. It can be the full, don't forget this. It can be the full disk. Don't have to partition things. And this is the 1 gigabyte. Okay, easy enough. We did it yesterday, many times. Not yesterday. Last video I recorded yesterday, but we did it many times, and it's all good. Now, let me add this here. Let's promote this to a physical volume. So this is basically going to upgrade the status of this partition to a special kernel device, which is going to be used on LVMs. And I'm going to use the command called pvcreate, and I'm going to specify the full path to this guy here. Okay. So first, oops, let me just do an lsblk here, so I get some way to copy paste. So pvcreate /dev this guy there, and now I want to list all my physical volumes. There are many ways you can do. Let me show you. You can do PVS. You can do vgdisplay. There's another one, pvscan. I forgot the pvscan. Sorry, pvscan or pvscan. So I'm going to use one or other or the other. It doesn't really matter. All will show the same information. Some in a way, some in a different way. It doesn't really matter. Let's do PVS, and I can see now that this is the one I just added here. This was the one that was already there. Okay. If I go do lsblk, you'll see that the P2 one it's this guy here. It's already a volume group that has two logical volumes. One is the root, so you can boot, and the other not to boot. This is the root file system, and this is the swap partition. So this one here, it's that one there. This is a primary partition for the boot. Like on the last video, I recommended that. Boot your system from a standard primary partition because it's easier to troubleshoot and it's just more reliable to boot. But you pick whatever you want because nowadays you can boot from LVM. It's fine. But I do prefer to boot from a primary partition. And this guy here, sorry, not that guy there. This guy here, it's this guy here, which means that there was an already present physical volume, which is fine, and that's okay. So if I go, this is my one here, this is mine, which represents now this structure here, okay? Now, I'm going to create a volume group on top of this. So it is going to be a group of one. It's kind of lonely, but that's okay. To create, I do a vgcreate. You kind of get the idea, right? And I'm going to call it vgnew. Why not? And I'm going to use this guy here. Now to see, I can do vgs, vgscan, or vgdisplay. I'm not going to tell you which one is the best because they are good in their own way. Just experiment. So vgs. I have a volume group. This is the one I have created. This is the one that was already there, where the root file system and the swap partitions are. So this volume group has two logical volumes. One is the root file system. The other one is the swap partition. One of the swap partitions, now we have multiple. Let's watch. Let's check. Swapon -s. So this is one of the logical volumes. You'll see that in a second. I'm building my way from the bottom to the top. Cool. Next, I'm going to create, this is our volume group here called vgnew. Okay. And now I'm going to create here, I'm going to use half the space to create a logical volume here with 500 megabytes. Okay. So this is the one I'm going to format, and this is the one I'm going to mount. Okay. Cool. Now let's do lvcreate. You kind of get the idea, right? I'm going to give it a name called lvnew1. It's fine. And this is a part where I usually make a mistake. I usually need to check the main page on the lvnew. Okay, so this is not enough. I understand. So let's do a vgscan. Oh, okay. I need to specify the sizing first. Okay, cool. Now I need to say how big it is. I said it was 500 megabytes. There are many ways to do this. I'm going to use the capital L to specify the actual size. Okay. So this is capital L allows me to say the sizing in a more human readable way. Megabytes, kilobytes, gigabytes, blah 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 bytes. If you use the lowercase l, you can say things like half the size of the volume group, or 1/3 of a size, or you can be a little bit more specific of your sizing. So because megabytes and kilobytes are a little bit too generic nowadays. If you use a lowercase l, you can actually say, be more picky about the sizing of your logical volume. In this case, I have created one successfully. So let's do an LVS. I'm going to put it here because I have to, but LVS, lvscan, lvdisplay. Okay, it's the same thing. So LVS, sorry. And there we go. I have here my lvnew that I have created on top of vgnew, which basically represents this. So this is my lvnew on top of vgnew. Quite nice. And it's 500 megabytes big, which means that if I do a VGS, I will see that my vgnew now has only, quote unquote, only 500 megabytes big because this guy took half of it. See, it's pretty simple. So now I will format this, mount this, and blah, 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 blah. Now I'll do a lvscan just so that you guys can see why is lvscan useful now. Because I am going to make the file system here, so I can just copy paste the full path of the kernel device. It's just that. So lvscan mkfs -t xfs, and I'm just going to copy paste this. Ciao. Done. Now I just need, as usual, mkdir mat lv Let me just copy paste lv1. Okay. Now, I really wish I could copy paste everything, and I can. So I want to put this on an fstab. So I'm just going to create a cheat sheet of sorts. There and there. Don't forget, I'm using the commenting out. So I'm just going to edit this fstab file, and I'm going to keep this handy because I'm going to need this. So you know the drill. This is going to be my custom LVMs. You don't have to do this, but it looks pretty. And it's easy on the eyes. So, bam. Again, you can use the UIDs if you want. It's fine. It'll do lsblk and you use the UIDs. XFS defaults 00. Looks good. I'm going to rush 7 quits. lsblk. If you think I'm doing some steps really fast, it's the good thing about videos and YouTube and all of that good stuff. You can just pause it and go back. And as you can see, it's not mounted yet. But if I do mount -A, I'm sorry, this is the set for status -A. This is, I can ignore this easily. And now it's mounted. Okay, which means that every file I put here, or well, when I read or write from here, I'm reading and writing from the device. So LVS, there we go. Now, what is a good thing about this is that if this runs out, I can add space to it. Okay, so let's make believe something like that happen. So let's do a disk free -H. This is showing me that this is how big it is. This is how big is available. I know I have available space, not much by today's standards, but I have some space available there, right? Let's make believe this is just ran out, or I need more for some reason. So what I need to do now is look at this and see what do I have. Okay, so the LV, it's let me put this one here. So the LV, it's 400 megabytes big or 500 megabytes big on top of VG that is 1 gigabyte. So hopefully I have some space here available to grow this one here, right? Hopefully I can grow this because this probably has some more extra space. Let's verify. So if I do VGS, for example, I can see that VG new where LV new is on top. If I do LVS, you can see that my logical volume is on top of this VG. So the LV it's 500 gigabytes. The VG has 500 gigabytes still available, which means I can grow my LV. So I'm going to grow the LV as big as the VG can give me. So I'm going to run out of space on the VG on purpose. So let's resize the LV first. To do so, I do lvextend. Okay. At any time, of course, you know this, but let me show you lvextend. At any time, we can go to the main page, and nowadays this main page is pretty cool because it has pretty decent examples. Okay, you can just come here and get inspired. Well, let me just copy paste this as inspiration. So let's do an LVS so I can know which one is which. So lvextend. Okay, I can say this in megabytes, kilobytes, or in this case I'm giving it more 50 more megabytes, but I can do something like lvextend. So let's do a small l. Let's say 100% free. Okay. Of our LV. Let me go back here so I don't remember. Let's try this. Okay, cool. I'm sorry, I forgot a little detail. You need to put here the plus so we can add, because as you can see, it barely grew. Okay. Let's do this. Now it's big enough. So add the plus to add space. So basically let me just rephrase that. So I'm extending this structure. This structure is showing me that the VG new has an LV. So this LV is on top of this, which is true. This LV is on top of this. So what I did here was to extend this guy using all the free space of this guy. So expand this using 100% free space of this. Don't forget the plus. The plus is very important. That's why the manual page has a plus. I just did not add it because I'm a dum-dum. Don't be like me. So this is going to extend this LV using all the free space that the VG can get me, because this LV is on top of this VG. If I go back to my LVS, you'll see that my LV now is 1 GB big because we started with 500 gigabytes. I gave him another 500 gigabytes, so it's around about 1 GB. But my VG new, probably, it's completely empty. Okay, so my VG has no space to give because my LV used 100% of the. Sorry, let's check this one. My LV used 100% free space of my VG, so I ran out of space on my VG. So if I go here, basically we are at this point. So our LV is using all the available VG space, which is fine. We can sort this out later. However, if I go to my df-h, you will see that even though the partition is 1 GB big, the file system, it's still half that size. Can you guys think about why? Why is my partition resized? My partition clearly is 1 GB, but the file system still thinks it's on the old one. Can you guys think about the answer? I know the answer, of course. So let me dive in that, okay? So basically, when we created the partition, it was 500 megabytes, right? And we made the mkfs command at this point. Now we have expanded this. Oh, you guys are not seeing. It's this one here. I'm sorry. So when we built the partition, we formatted using the command with the partition with 500 megabytes, right? In the meantime, we have expanded it, but the file system still thinks it's at 500 megabytes. So you need to insert the file system to say, hey, guy, please, I have more space now. Go and check it out. So you just have to do xfs grew fs. Why? Because we have the file system we created was xfs, so it makes sense. And in the perfect world, you just do this, and he will just understand the message. Okay. So we'll just make since the file system we made was xfs, you just say grow, please grow, and he grows to the maximum possible size, which is the 1 GB. No formatting, no rebooting, nothing of that sort. The file system just grew, and we are good to go. And this is, if indeed it was a 500 terabytes file system, it will grow as fast as this. Okay, it's really snappy, especially if you are using cloud resources. Cool. Now let's go back to our drawing board here. So let's say I want to create an LV2 here. I want to create a second LV. Can I do that? No, because my VG it has run out. So I want to expand another gigabyte here. To expand here, I need to go here, I need to go here. So let's create a new partition 1 GB big, convert it to a VG and convert it to a PV and expand our VG. Okay, so let's go back to the beginning. Gdisk. Let me just, I forget the name, but I can do this gdisk. This guy here, yeah. We will print new 4 fine 1 GB. 8. You know what this is? It's 8000, and it's LVM. We write. We say yes. We part probe. Be careful using part probe. And the whys are on my previous video. Go and check it out. Like and subscribe. And I do the cat proc partitions just to be safe. It's there. My P4 is there. Nice. So clear the screen. PVS. My P4 is not there. So pvcreate. It's going to be the 4. PVS. Very nice. Now this is my device belongs to no one. I want to expand this one. I could create a new VG, but I want to expand my VG to another gigabyte. So vgextend. This guy, I'm sorry. this guy gets this guy. Nice. VGS. Cool. Now it has free space. If I go back to my PVS, my VGNew has two devices, two of 1 gigabyte. So total space is 2 gigabytes. So VGS, it's, well, free 1, but total 2. So which means that if I go to my LVS, this is the guy already I have there. I can create an extra one. Let's do lvcreate -n lvnew 2. It's going to be 500 megabytes big, and it's going to use vgnew. LVS. So my lvnew 2, it's on top of vgnew and using 500 megabytes. So if my vgnew had 1 gigabyte free space, I took 500 megabytes. So this is going to show me 500 megabytes of free space now. Makes sense. Now everything, it's back to the drawing board. You create a file system. LVS, lvscan. Form of mkfs -t xfs. This is the new. Remember, if you format twice, you will get notified. So it's kind of almost impossible to format a drive twice without getting warned. So you should be good to go. So nkdir mnt lvnew 2. Let's take our cheat sheet here as usual. So we can copy paste to fstab, v-etc fstab. Now I have my custom thingamajiggies, looking pretty nice and pretty. I copy paste things incomplete, that's fine. Let's go back here and copy again. Let's go back here. My custom LVMs, bow, ka-chow. If you want to be as lazy as me, I will copy paste this. Oops. Mount -a. LES. Yeah, -h. There we go. And now I have my new logical volume mounted, which is don't forget my vgnew has 500 gigabytes free right now, right? Which means I can expand this one, I can expand this one, or I can create a third one on top of this. See? This is how dynamic this can be. I could create a swap partition, I could create whatever. It's just when you do all the steps, and the main part here is on the formatting. So until you get here, you do the create, and then this can be a swap partition, it can be a regular partition. It all depends how you format and how you mount. All right? Pretty cool. So if you want to rewatch this as many times as you want, you should. Ask down below any questions you may have about LVM and about this quick example that I just shown you. I have been using partitions, but you can use full drives. You can use the full hard drive for that. You don't have to use partitions. You can just PVS the hard drive or the storage device, and you're good to go. You don't have to partition in order to do so. So next, I'm going to do stratis. I'm going to look at my cheat sheet because I don't remember from the top of my head. But stratis, it tries to work as the same as LVM, but it uses a service. In theory, it's more simplified and more streamlined, which I don't agree on 100%, but it's fine. I don't use stratis in production. I don't think you should do it in production either. But anyways, I'm going to show how can you use stratis in a similar way. I'm going to look at my cheat sheet, so I might just stumble a little bit on my commands, but it's fine. And basically, this is going to create a data pool. So it's kind of quote unquote simplifying the pvcreate, vgcreate, and lvcreate. I don't think it simplifies nothing. It just complicates by adding a service in the meantime, in between. So get yourself comfortable with LVM. It's not that hard after a few tries, and stratis will just become a little bit uninteresting. But I would not forget myself if I wouldn't show you. So here we go. So first, make sure that it's installed. I probably don't have it installed. So dnf install. What is called stratis something. Stratis CLI. I think this is a command line, and stratisd. It's the service. I think I'm correct. No, I mistyped something. Stratis. Okay. You say yes. I don't like this, but I have to show you. This is the goal of this chapter. Cool. Now, let's make sure this is enabled and started at the reboots. Not that. Systemctl. Enable. Minus now. Stratisd. I know it is, but let me just make sure. Status. Okay. Yeah, looks fine. Cool. Now, what we're going to do here is add devices to the pool. Okay. So I need to do similar things like I did for LVM. So let's see, lsblk. So I'm going to create a couple of partitions. Primary partitions would be good enough. I could use GPT, I could use MBR, I could use full drives, you don't have to be partitions. Take your pick. So, I mean, I have space here. So let's go to the gdisk. We're going to print. So let's create a couple of partitions. Just to make it different, let's do it a 2 gig, new partition. Regular partitions are good enough, right? Yes. Parts probe. lsblk. Cool. I have 2 partitions here that I can just add to the stratis pool. And let me go to my cheat sheet. Okay, so let's create a pool. Stratis pool create /dev. This guy. No, not this guy. This guy here. Okay. Pool create, status pool create. I need to give it a name. Let's call it pool 1. Okay, we created pool 1. Now we used to do stratis pool, stratis. I hate this. Stratis pool list. I have a pool that is made of 1 device. And it's 2 GB big because the device was 2 GB big. So this is kind of a pvcreate plus vgcreate in one sitting. I mean, it is what it is. Okay. Now, if I wanted to add a second one in the future, so an lvextend of sorts, we can do stratis pool add data pool 1. And you specify the device. And if you do the pool list, now it's made of 4 GB big because it's 2 GB partitions. So this is kind of a pvcreate plus vgcreate. This is lvextend. It's kind of I mean, I don't like it that much. Then you can create a file system. So stratis file system. Create. Let's give it the name of the pool, of the VG in a way, right? And let's call it FS1. So this is our mkfs. As you can see, I was not able to specify which file system because Stratis uses XFS exclusively. So Stratis file system list. There we go. Okay. It's always XFS. And will always show you a 1 TB big file system. I mean, it's not something you can just say whatever you want. Nope. It's XFS always, and it shows you always as 1 TB big. Okay, what we do next? We mount it, right? So in order to mount this, you need to do fstab things. mkdir, etc fstab. No, never mind. mkdir, mnt, let's call it stratis. Okay, mkdir. Let's get our sheet going. So this is our device. We can use the ID again. It's fine. And the folder, now you just do etc fstab. Cool. Now let's do, let's put it here. My custom stratis. And go here. Shazam. Oh, again, I forgot to copy paste this part here. Delete this, add this here. Bam. Cool. Now, you need to be careful because if it was a regular partition using kernel drivers like LVM, it will just do the thing you did here, right? But nope. This is a special one. So you need to do defaults. It's so far so good, right? Defaults. But now you have to tell the system you need to wait for stratis. So basically, since these are all kernel drivers, you just boot to serve the system and the kernel takes care of everything. In this case, to have access to this, you need to wait on the reboot for the systemd to be served to systemd, which is, if you remember correctly, the thing that gem manager services. You need to wait for systemd to start the stratis service so you can mount this. I don't like this at all, okay? These are kernel drivers. They are ready to go most of the time. Here, it depends on the service to have access to your drives. I say nothing else. It's fine, it's there, it works, it looks great. 1 terabyte, it always shows up as 1 terabyte, even though it's just 4 gigabyte. It always shows as XFS because that's kind of, you need to use XFS for the to the strategy things to work. So it is what it is. So this is stratis at its best. So going back to the commands, if your stratis pool runs out of space, you just get a new device, partition or full hard drive, and you just add to the pool and you're good to go. So it's kind of in my mind at least, it's a hyper simplified version of LVM with, well, too much simplified. The fact that it's depending on the service, it kind of makes me nervous, but it's me. I would not stress test with production level stuff, but for a quick data pool that's expandable, it's okay, but make sure your backups are up to date. So that's all for chapter 8, managing storage stack. We checked LVM, we checked stratis. Like and subscribe, it really helps the channel to grow. Comment down comments, which also helps a lot the channel to grow, and mainly use the comments to ask any questions, doubts, or anything I can do to improve this series. Like and subscribe, it really helps, and I'll see you in the next one. Cheers, guys.